So our vision is that these cars running all of the AI networks that I just described, connected to HD clouds, should be able to drive from address to address in a very large part of the world. However, there are always places where the confidence of the AI, the confidence of the car, is not high enough to drive by itself. But because it knows where it's going to go, it knows the path. It could determine its confidence level in different parts of the path. And it could tell you which part you should drive yourself or it has low confidence in supporting. We believe that the car is going to be an AI car for driving, but we believe the car itself should also be an AI co-pilot. So ladies and gentlemen, today we're announcing a new capability on the Nvidia AI car computer. It's called the AI co-pilot, and it basically works like this. Remember, the car has sensors all around it. It's got cameras, it's got radars, it's got lidars, so it has surround perception. The car also has cameras and speakers inside the car. And so it has internal car perception. It is aware of its surroundings. It's aware of the state of the driver. It's aware of the state of the passenger. And just as the Nvidia Spot gives you an array of speakers and microphones, there's an array of speakers and microphones inside a car. And so this car has incredible perception capability, if only the AI was running all the time. We believe that the AI is either driving you or looking out for you. It's either driving you or looking out for you. When it's not driving you, it is still completely engaged, even though it doesn't have the confidence to drive, because maybe the mapping has changed, or maybe the road is too tricky, or maybe there's just too much traffic, too many pedestrians, and that it shouldn't drive. It should still be completely aware, and it should continue to look out for you. We call that AI co-pilot. Surround and environmental awareness, as well as in the cabin, passenger driver awareness. Let me now show it to you. And so what you're looking at here is the four cameras.
There is a bicycle on the right 45 feet ahead.
So notice there's four cameras, front, rear, left, and right. And the front camera, notice there's a biker to the in front of you about 45 feet ahead. And maybe your eyes aren't looking in that direction. Maybe your head's not looking in that direction. And the car realizes that you might be more cautious. And in this case, it detects that there's a biker and tells you through AI, natural language processing. And so by talking to you very naturally and alerting you of the condition in front of you. Here's another example.
Careful, there is a motorcycle approaching the center lane.
And so in this case, the idea is relatively simple, incredibly complex to execute. You have to understand what you're seeing, and you have to convert what you're seeing into natural language, otherwise known as captioning, and then saying it in a natural way in the car so that we can understand what the car would like us to be concerned about. And so that's environmental awareness, surrounding awareness. We also would like to have the capability for inside the car AI. The AI should be paying attention to you too. Maybe you're not looking where you should be driving, where you're driving. Maybe you're dozing off. Maybe you had a little bit too good of a time. The AI should pay attention. Maybe the AI notices that you're a little bit aggravated and probably should pull over. Too much road rage. And so those capabilities modern AI networks can absolutely do. And so let's take a look at that. Okay. So this is Janine. This is one of our employees. Like, hey, let's put our hands together for Janine. So the first network does facial recognition. Okay? And it does facial recognition incredibly well. This is deep learning facial recognition networks are among the best in the world, and it's reaching human level capabilities. This next one is head tracking. By looking at Janine with a camera, the artificial intelligence network is able to determine where her head is looking. Okay, this one's really cool. The artificial intelligence network, the deep learning network, just by studying her eyes, is able to figure out what direction she's gazing. Maybe she's looking at, no, shouldn't do that. Okay, so that's called gaze tracking. And this next one is really cool. This is inspired by, this is lip reading. Take me to Starbucks. And so if your car is too noisy, and there are too many people talking, and yet you said something rather important, wouldn't it be nice if your AI car was able to recognize and read your lips and determine what it is that you said? This particular capability was inspired by the researchers at Oxford working on the LipNet, and they've been able to achieve a lip reading capability that's 95% accurate. A human, the best human, is about 53% accurate. And so this gives you a sense of the state-of-the-art of artificial intelligence networking. You combine what I just described on the external surround perception capability and in-car passenger and driver perception. The combination of that allows us to always be aware and to keep the car, keep the driver as alert as possible and always be on the lookout for us. Not to mention all of the things that I described to you earlier about Shield and Google Assistant. We'll surely have that assistant capability inside the car so that you can talk to your car and get whatever access to any information or enjoy any content and media you would like. This is the Nvidia Ai Car Platform. From the bottom up, starting from the bottom, this is the Drive PX computer. And on top of it is the DriveWorks operating system. These two things are probably the most complex computer that we have ever built, and we built some of the most complex computers the world's ever known. The amount of data that's coming into this computer, the richness of the artificial intelligence networks and algorithms that we have to run, and the performance by which we have to run it, because time in the case of a fast driving car is reaction time. And reaction time is safety. And so it is vital that we do this very, very quickly. On top of that are all of these artificial intelligence networks that I talked about. There's the autopilot AIs. Perception of the world, reasoning about where you are, reasoning about where everybody else is, driving the car, continuously mapping the car, and exchanging that information with the HD maps in the cloud. Make sure that all the data is coherent and things are changed if necessary. The co-pilot deep neural net, so that there's an AI that's watching out for you all the time. It might even, in the near future, say something like, Jen-Hsun, you're driving up the hill, you'll be home in 5 seconds, would you like me to go ahead and open up the gate? So that by the time I actually got there, just a second prior, the gate opens up and I pull right into the garage. The AI co-pilot. We also need the ability to converse and interact with our computer in a very natural way. So natural language processing has to be done inside the car so that if the connection is not very good, you can still communicate with the car. And that the reaction time, the latency between your spoken words and its recognition of your speech is as fast as possible. And yet it's connected to the cloud to an AI assistant. This architecture, on top of that, is an API called MapWorks. This is one of the most important things we do. MapWorks interacts with all of the mapping companies in the world. And it does basically 4 things. We basically do 4 things with mapping companies. The first, of course, is the surveying car. Some cars record all the data and do the processing on GPU supercomputers in the cloud to extract the 3-dimensional data from the video. Some survey cars do the processing using a computer like Drive PX, either one of these or something with a Nvidia discrete GPU, so that it could essentially do mapping in real time inside the car. So that's survey car. Number 2, is the GPU supercomputer that's inside the cloud for mapping. Number 3, the interface of data, the exchange of data, so that our car can always see the HD map in the nearby surroundings of the car. And then number 4, as we continuously map the world and notice changes, we would update the changes to the live map in the cloud. These 4 things, these 4 functionalities is vital to the ability for self-driving cars to be realized in a very high confident way. And so we've been working with the world's leading mapping companies. We announced several weeks ago, I guess a few months ago, the leading mapping company in China, Baidu. Incredible partner of ours, working across all 4 layers that I described, all 4 functionalities that I described, from surveying all the way to map processing, all the way to synchronization with the local computer inside our car. The reason why Baidu was so important is because every car company in the world and any car you build should be able to drive anywhere in the world. And China is now the world's largest car market. It is too large to ignore. And yet, only a Chinese company can map China. And Baidu has mapped more of China than any other company. And so partnering with Baidu was a very logical first. We then partnered with TomTom, leading mapping company in Europe. Today, we're really super excited to announce that we're partnering with Zen-Rin, the leading mapping company in Japan. Japan's roads are incredibly complicated, and it is such a dense population. The mapping of Japan is quite an extraordinary task. Zen-Rin is an amazing company, and we're working with them to map Japan. And then also today, super excited to announce that we're working with HERE to integrate Nvidia technology into their data centers for mapping, working with them on map algorithms, as well as connecting to all of the Nvidia AI car computers inside cars as we synchronize the live maps. Let's thank all of our partners to make this, create this incredible dream.